Hello, let us discuss about how to plot a box plot in R programming. So for that we are using this R Studio, and particularly I open the R notebook here. So the advantage of using R notebook is we can view the output here itself in the program. Like you can see the one which has been written in this place. For example, you can see this module, we call it as a chunk. Okay, so you can open a chunk and we can run the programs individually using the chunk. So if I want to run here, then I can just show the output at the bottom, like you can see immediately after running the program, right? So now let us see this box plot. So this is the data set which we are going to use, okay, which is called faithful data set. It has got two features. One is eruptions, the other one is weighting. So we are going to draw a box plot. Okay, the command is box plot for this column weighting. Okay, so in faithful dataset we are using weighting, so we have to use faithful $weighting, and I'm just going to give a name for this box plot, weighting variable in faithful dataset. Okay, and I'm going to color this with some color yellow. Now after doing that, I just want to find the quartiles, because usually box plot is plotted by using the quartiles, and in quartiles you can see the middle one which is called the median. Okay, and 25 percentile which is called Q1, and 75 percentile is Q3. So in between the ranges, interquartile range, that will also be found by using this program. So once we run this chunk, we'll be getting the output. So I'll just run this, and this is the output which we got. So here is the data set. Okay, it is in the data frame, you can see. So we have up to 272 records in this data set. Okay, so in this especially we are going to go with only weighting feature. Okay, we are just taking this weighting variable and trying to plot it as a box plot. So this is the box plot created, you can see. So what we understand from this box plot is, you can see the line here, the thick black line which is called the median. So this is here 50%. Okay, so Q2 is 50 percentile, and below this you can see this, the bottom line which is Q1, and at the top in this box which is Q3. So what it represents here is, actually this is the left skewed distribution, because you have a long, like tail in the left side, so that's why it is called left skewed, or negatively skewed we call. So and there is no outliers in this. Okay, so we don't have an outlier in this. That means the whiskers which are covering the lower part and the higher part, okay, the maximum whisker has covered all the data in this data. Okay, I mean the values in the data, weighting data, it is covering every data here. So that's the reason we don't have an outlier, it is covered by the maximum whisker here. And once we can see this concept, we can also understand about the quantile and interquartile range. So quantile is, you can see this quantile here. So we have this 0%, 25%, 50%, 75%, 100%. 0% nothing but the minimum value, 100% is the maximum value in this weighting column, and 50% is the median. Okay, that is Q2, 25% is Q1, and 75% is Q3. Okay, so these are the quartiles, and this 24 is nothing but the interquartile range. That means we are going to subtract Q1 from Q3, Q3 minus Q1, that will give you 24. So this is about box plot. Right, now we don't want to see this, just click here, it will go. Now we can just go with this question. Okay, I just inserted this question by some commands here. Okay, by using knitr in graphics. So this is the question. Now here the number of tornadoes, you can see here a 4-month record for the number of tornadoes in 2003 to 2005 is given here. So there are 3 years, and there are 4 months here. So tornado is like a storm which is usually happening in the western country. So we are just taking these records. Now we are going to plot the box plots for 2005, this year, 2004 and 2003. So when you want to do that, you have to be aware of using the matrix here. So how to create the matrices? We just want to go with this command. Okay, we are going to open a chunk. Okay, so how to open a chunk here is, like, let me open down and show you. So this is, you just click here and click the first one, this will open a chunk, you can see down. So this is the place to write the command. So I don't want this, now I'm just going for this, already it's there. Now I'm going to create a vector, okay, where I'm going to give year as a variable, and just type 2005, 4 and 3. Okay, and then I'm going to create another vector, like you have 4 vectors, because I just want this row. So one second, want this April row, you see 132, 125, 157, that row. Like that I'm creating row wise 4 vectors A, B, D. C is the command for vector, so I'm not going to use that as a variable. So A, B, D are the 4 vectors created. I mean the rows are created here. Okay, so we just took these rows now, right? Now what we are going to do is just we are going to create a matrix by using these vectors which are created. Okay, so here I just give d2 is the variable which is assigned for the matrix, and C of ABD we are just going to take all this, okay, vectors inside and form another vector, okay, C of ABD, where you can see the rows. N row is 4 rows here. Okay, so n row is number of rows which is 4, n column is 3, and by row equal to true, in the sense this matrix will be printed by the row. Okay, if you put by column equal to true, then it will be printed as a column, but here it is going to print as a row. As such you can see here, so this command as such it is going to print like this. Okay, this question, so that is why I have given this by row equal to true. Now even I can see that by using print command, and after that I'm going to create the box plot by giving this command box plot of d2, column is light green, that sorry not column, color is light green here. So I'm just going to give the color as light green, any color you can give here, and names equal to year is nothing but this box plot has been plotted for this years, right? So each year I'm going to see that I mean give it in the output even. Okay, so for that I'm just taking this here, this variable, and putting it here, right? And I'm going to find the quantile for all this, 2005, 2004 and 2003. So for each column I'm going to create, so that's the reason I just made quantile of d2. In that I need first column, right? So in the matrix, first column I need, so I mean this first column, so I just put 1. If I want second column I'll put 2, and third column I'll put 3. Okay, so like that I just want to plot it. So I'm going to plot all these things. Let us run this code and see. So we'll run this. Now you can see this beautiful box plot plotted for all these 3 years. You see 2005, 4 and 3, and it is in the bottom, you can see that. And in the R console you can see the quantile even, because we need, see this matrix has been printed exactly as same. Okay, this question you can see this matrix printed here, and for the first column, that means 2005, we can see the quantiles, that means the minimum maximum q1, q2, q3 values, and second year, third year also you can see this quantiles. And you can see this box plot, and you can compare among the box plots, okay, like which is going to be symmetric here, or whether it is going to be left skewed, right skewed. You can see in this box plot is having a long tail in the right side. This box plot has got even the long tail in the right side. Okay, so it is right tail. This is also right tailed, right skewed, we can see. Okay, so this are some interpretations about the box plot. Okay, and you can see where is the median range, which is 50% here. Okay, you can see the black thick lines, and below that how much data is covered, above that how many data is going to be covered. So these things we need to be understanding here, right? So this is the interpretation of box plot. So I hope with this we can understand how to plot a box plot and how to interpret the data. Okay, so thank you so much.